Welcome back, guys. Today we are gonna continue with database management system. We're gonna read fundamentals of database systems book. So we'll begin with conflict equivalence of two schedules. The conflicting equivalence of two schedules is nothing but the relative order of the conflicts which occur in both the schedules uh, is the same in both the schedules. And as we know that two operations in schedule are set to conflict if they belong to different transactions. If, if the two operations belong to different transactions or they access the same database item or either of them is a right operation. These three are most crucial points to for operation to be considered as conflicting. If, and if the relative ordering of these conflicting operations is same in both the schedules, we can say that those are conflict equivalents. See, they have explained with an example like we are reading uh, in transaction one. This is the operation of transaction one, which is reading X, and this is the operation from transaction two, which is reading X or writing X. So they are, if you reverse the order, the final output of the or the we can say the result of the database can vary depending on their order. So basically the main idea is the relative ordering of the two conflicting operations should be same in both the transactions. If they are not same, then the result of the database will differ. So they have explained with the example. They have given this operation is from transaction one, and this operation is from transaction two, and they are both in the same schedule. And if the order of these differs in both the schedules, the result of the schedule of both the schedules will to differ. And let's move to serializable schedules. Serializable, which means if we have non-serializable schedules, means we have some what we can say is serializable is nothing but the schedules which can be converted into serial schedules. And serial schedule is nothing but each transaction occurs consecutively. There are no interleaved operations in single schedule. Basically, all the transactions are independently operated, and serializable schedule are the same, which means we can convert a schedule into serializable if it can be converted to a serial schedule. Means basically the result of a serial schedule matches with this kind of schedules. Well, I'm, I'm pretty bad at explaining, but I'll try to improve with time. So let's move to serializer schedules. Basically, if two schedules are conflict equivalent, they are serializable. And I have explained what conflict equivalent are. If if two schedules are conflict equivalent, then we can reorder the non-conflicting operations in S1 until we form equivalent serial schedule S prime. Basically, S is a non-serial schedule and S prime is serial schedule. And we are converting serial non-serial schedule into serial schedule. And if it's possible, then we call non-serial schedule as serializable schedule. So according to this definition, we are saying that this non-serial schedule C is equivalent to serial schedule A, and let's see why. I mean, my bad. They're talking about schedule D and not C. Schedule D is conflict equivalent to schedule A. They are saying that. Let's see why it's possible. So in both the schedules, in transaction T2, if we observe the item X is red, which is written by transaction T1. If you observe, and here we are reading item X and transaction T1, which was um, fetched from the initial database state. Um, and basically T1, T2, write item. Basically T2 is the last. At last, we are writing item Y in transaction 1, and in transaction 1 same we are writing Y at last, and same for T2, we are writing item X and writing item X in transaction T2. So as those are uh, as we have seen that these both are conflict equivalent, when then we can move uh, this read item X, basically update transaction T2 below, and we can move this above, and we can finally like we can finally form schedule A from this. So the main thing I have to mention is, see, we are gonna just observe the order of read and write operations as they are mentioned. If read and write operations, the relative order of read and write operations in both the schedules is same, then which means also the only ones which are forming conflict. Wait, I'll make that thing clear. See, it's clearly mentioned that the relative order of conflicting operations is same in both the schedules. So we are just going to focus on the relative order, which are of the operations which are going to conflict. So here, the only operations that we know are uh, conflicting operations are write write, read write, or write read. So write read read. But actually, that's not conflicting, but write and read is conflicting, and it's happening on the same data item. So, write read. So the relative order of these conflicting operations is the same in both these schedules. And let's move to write. And even that's the same. Write. The relative order. I mean, not this one. My bad. Only these two writes and reads. Basically, we are fetching the item. We are reading this item from previous database state. So it's same for both. Let's move to the next part. So coming to the schedule C. See, they have uh, explained here why it's not serializable. Because if we try to check the operations, the relative order of the operations which are conflicting, we'll find that it differs. I'll just highlight it, you guys can read it. So here in transaction T2 for schedule C, in schedule C, write item X is coming before read item X is coming before write item X, and it's right. If we see for the same, it varies here. So from here we can conclude that these both are not conflict equivalent, and we cannot read or receive to get schedule A. So with this portion, we'll read this portion in the next video. Until then.